In this video, we're going to continue with some of the definitions for quadratic functions. However, we're going to focus mostly on definitions that use, or definitions that talk about the focus, directrix, and what those things relation to the quadratic function are. And so there's four ways that a quadratic function can open. Okay, quadratic function can open upward. It can open downward, it can open to the left, and it can open to the right. However, these two things, opening to the left and opening to the right, are not functions. Why are they not functions? Because they fail the vertical line test. If I draw a vertical line anywhere in those, you can see it crosses twice. So neither of these are functions, because it fails the vertical line test. Now, the direction of opening for the definition here, I'm just going to simply put the direction in which the cup opens. Okay, the direction in which the cup opens. And what I mean by that, or I could say the direction in which the U opens, U, cup, whichever one you want to use, but you can see the U shape opens upward, the U shape opens to the right, opens to the left, or opens down. And so that's what we would say. And then the example that you have on the paper, which is not up here, it's on your paper, it opens downward. Opens downward. Okay, now the vertex is the exact same. Once again, I don't have to do anything. It's just the point the point at the maximum or minimum at the max/min. So it's just that idea of the very top, like absolute value, that very top, or that very bottom, same thing. In this case, it's the very bottom. And in the case of the one on your paper, it's at the very top. And so on your paper, once again, it's here, and that would be at 2, 1. So on the paper that you were given for this, it says 2, 1 would be for the example. Now, focus and directrix have very specific definitions. So instead of me just remembering it off the top of my head, I want to make sure it's correct, exactly, and so they're very, very intentional about these two things. Okay, one is inside and one is outside, and so this is the point inside the cup. As you can see, it falls inside the parabola or the quadratic. It falls inside of there. And the directrix is the line that falls outside the cup. And you can see here in this example, it falls outside the cup. But there's a really, really important thing that you need to know about the focus and the directrix. And that thing is down here. It's already written for you at the bottom. It says the focus and the directrix are equally spaced apart from the vertex. As you can see, that right there and that right there are equal distance. Equidistance is how you say that, equidistance, between the vertex and the focus and the vertex and this line, the directrix. It also says the vertex lies halfway in between the focus and directrix. These two things say the same thing. In other words, if I take the total distance, divide it in 2, that's where the vertex should be. That's what the second one said. The first one said the two distances are equal to each other. Same thing. Okay? P-value is the distance from the focus or the directrix to the vertex. So the distance to the vertex from the focus or directrix. Okay, now I haven't filled any of these out yet, but I'm going to go ahead and just wait till after we do the rest, and then we'll go back to the example for these four. Axis of symmetry, once again, it's the exact same as before. That's just the x value of the what? X value of the vertex. So now that we have all of these things, we can go back to the example that's on your sheet. Okay, the focus is down below the vertex. You can see in the graph, down below the vertex at 2, -2. 2, -2. What do you notice about the x value of these two, the vertex and the focus? The x value is the same because the x has to line up on this axis of symmetry. So in other words, this is x equals 2. Once again, the x value of the vertex. Now, directrix is not just a point. Directrix is a line. Okay? If it's a horizontal line, does anyone remember horizontal is x equals or y equals? Horizontal is y equals. And so we need to find the value of where that equals. And so it's at 4. You can look in your paper, follow along. It's at y equal 4. Okay? So it's kind of like the axis of symmetry is a x equals line. It's vertical. Directrix is a horizontal line, y equals. Okay? And then the last thing is p-value. And remember, p-value is the distance between the vertex and the focus, or the vertex and the directrix. And so if we look on our paper and we see the vertex and we count from the vertex to the line at the top, that's 1, 2, 3 distance. Or if I go from the vertex down to the focus, that's 1, 2, 3 distance. And so the distance between the vertex and the directrix, or the vertex and the focus, is 3.